PCR, or polymerase chain reaction, is a process we use to create more copies, and by more I mean a literal billion, of a specific section of DNA. Tongue twister. This is useful for detecting viruses, analyzing crime scenes, and a lot more. So, first of all, there are three main stages of PCR, and those are called denaturing, annealing, and extending. So let's just make ourselves a little model right here, and to do that, I've got some different pieces of paper. So this is a little model, very rough model, but this is just to show these are the two sides of DNA. So you'd have, like, this would be the 3 end, and this would be the 5 end on this strand. This would be the 3 end here, and the 5 end would be there. So in the denaturing stage, the DNA gets heated up to 95 degrees Celsius, which is really close to boiling, but just barely not, which causes the hydrogen bonds to split. The hydrogen bonds would be right here, and that's what is actually attaching the sides together, so that causes them to split up. So we can, quick demonstration, they split up just like that. The next stage is annealing, which is where the primers attach to the DNA. To represent the primers, I've got these little pieces of paper right here, so we can say the primers would basically attach, like, say, right there. Oh, and then right there. That is, no, that's not the reflection. There we go. That's, so yeah, that's where the primers would attach, just for this example. So that's, this is the stage where those attach. Those locations are determined by the primers. So the primers know where to attach because of the codes within the primers themselves. The primers are a sequence of nucleotides that match the beginning of the STR, or gene of interest. The DNA is cooled then to a range of somewhere between 40 to 70 degrees Celsius. Yeah, surprisingly forgiving, considering this is science. Then the last stage is extending, which is where the Taq polymerase is added to the DNA and heated back up to 72 degrees Celsius. The polymerase reads the primers and calls over the specific nucleotides to extend the strand. So what happens there, to demonstrate it, and so it's not just reading off a whole bunch of words, we've got, ooh, where's the next size in my paper? I think it's this one. This is the next size. I didn't do that. Oh, also, I guess for the example, it works better like this. Hold on. I'm a little off with where I put them for my example. So it would happen like this. This would be what roughly would it look like when extending. So you see from here is the primer. It reads and it copies over with nucleotides reading down. Now this isn't the end of it. This actually just goes on for the rest of the entire DNA strand. Now this entire process gets repeated. So it can create more copies, and as few as 30 cycles, 1 billion copies are made. So let's just run through that a couple more times. It would be running through, I'm not going to fully explain it again, but just, the denature stage. Then let's just remove the primers for now. The denature stage would separate these. Primers come in and attach. They attach in the same spots. So we got, those two where we had them before. Now we got to add a couple more right there. And then one up here. Then these might be a little too close together at the moment. There. And then we see they'll copy over again. Just like that. Now you can see from this stage, after repeating it again, now this section is the section that we were first looking for. You can see, and you can tell that because the end of it, each end is touching where a primer would be. So now if you did repeat this again, I'll just focus on this one for the example. If you repeat this again, which one do we want to focus on? We'll focus on this one. So see that? You'll see a primer is going to attach right here and right here. I'm just looking at this blue strip just for now because I don't have enough paper to demonstrate the other. So I'll just move them out of the way just for now. You'll see the primer's attached there, and then another piece gets copied, and now we just have this section. This is just the entire section of, this would be the STR or the gene of interest that we're looking at. This is it. And that's just a couple cycles to get to that, and then by continuing the cycle, you can end up with billions of copies. So yeah, thanks for watching that quick rundown of how PCR works. And first of all, if you're a viewer on my channel, hopefully you enjoyed and maybe learned something new. And if you're my teacher, hopefully that's an A. Bye.